Hello guys, today we are going to see about most important design pattern, that is singleton design pattern. Not only important but it is widely used design pattern. Almost all the systems will have a class, at least one class which is implemented as singleton design pattern. So this singleton design pattern comes under creational design pattern category. So it deals with the problem of creation of object. So that's why it comes under creational design pattern category. And as the name suggests, something can be created only once. Okay, so that's why it is we are named this design pattern as singleton. And as I have already mentioned, it is a creational design pattern. So it deals with the problem of object creation. And as the name suggests, only one instance of the object should be created from this class. So obviously, from the name itself, we can say at so only one object should be created for that class. Okay. So here, uh, the problem this design pattern solves is, if we follow this design pattern, it will make the class such that at any point of time during the lifetime of the application, only one instance of the object will be present. It is not possible to create more than one at any point of time for the class. So that is singleton. So singleton is single object only can be created for the class which is implemented as singleton. Okay. So that is the problem it's going to solve. And so if we want any class that need to be uh, create an object with only one instance, then we can follow this singleton design pattern. Then then at any point of time, if we follow the singleton design pattern to the class, then at any point of time only one object will be present for the class. Okay, so this is singleton design pattern. So I'm going to uh, so the problem here is we are creating a class, but we want only one instance or object of the class need to be present at any time throughout the lifetime of the application. So the solution is follow singleton design pattern. So this is the problem this design pattern going to solve. And this is about the introduction to singleton design pattern. So let's see what are the applications. So why we need only one instance of the object for any class. So let's see the application in any of the real-time scenario. So one example is database connection. So in any application we have some database, and any number of connection can be made, but we can limit the connection to have only one connection to the database, so that the database operations will be efficient, so that we can make that database connection as singleton, so that at any point of time only one connection will be made to the database. So that is one example. So database connection is an example for singleton design pattern. And there are many other examples. So another example is logging. So consider we have an application, and an application will have multiple modules, and in each module you should enable the logging. So to if we enable that logging, it will create an object for logging and logger, and it is responsible for creating the log file and able to log the that particular module logs. So here, if we create a particular class for logging, and it is responsible for creating the file and logging the information. So different modules are using this logging, so different file will be created. So what if we need to have only one single log file for the entire application? So all the modules should log everything in the same file. So what we can do is we can make the logger class as a singleton object, like singleton class, and so whenever any module is using that logger class, it will be able to create only one instance, and the same instance can be used by all the modules. And since we are having only one object of logger at any time, so it will be able to create only one file and able to log it in the same file for the entire application. So that is one example. So another example is a logger manager, and we have a lot more examples, lot more applications for this singleton. So let's see how we can implement singleton design pattern. So we have seen what is singleton design pattern and what is the problem it is going to solve and what are the applications. And now let's see how we can implement this singleton design pattern. So now we are going to see the implementation. So basically we need to follow these three steps for making any class as singleton. So first one is make the constructors private. So we need to make the constructors like default constructor, parameters constructor, or copy constructors as private, so that this class cannot be instantiated outside the class. So only inside can be instantiated. And we need to create a static member variable. The static member variable should be a pointer of the same class object, and it should be initialized with null pointer. And we need to create a static function get instance, which should return that static pointer value. So if this pointer is null, then it will create new object inside that function and assign it to that pointer. And if it is not null, then it will return the same object which is assigned already in that static pointer. So these are the basic three things we need to do. So make constructors private, then we need to create static member variable, and we need to create static member function. Inside that function, we need to return that value inside that static pointer. So this is the basic idea for so if we follow these three steps, then the class will become singleton. So let me show you a code example for this. So I have already written the code, and I will copy paste in this notepad. So this is a singleton class. So I am creating a class as singleton. Okay. And what I have made is I have made the constructors as private so that it can't be instantiated outside the class. If any class is trying to instantiate the singleton class, then the compiler will throw error. So it cannot be instantiated outside the class. For accessing the object of this class, we need to call this get instance. So inside this get instance, if you see the pointer, if it is null means we will assign the new object created and we will return it. So this is the basic idea of singleton class. So this private constructors and static member variable and static member function get instance. This makes the classes singleton. So we can access the object of this class only using the get instance. So this is the implementation of singleton, but there is a twist in this. In case of multi-threaded application, if two threads calling the same function get instance, then two instance will be created. How? I will explain how. So here line number 30. So one thread is trying to come at line 30 and it will check the pointer is null. If it will be null, then it will be passed and another thread is calling the same get instance and come to line number 30. The time also it will be null because the thread 1 didn't enter the line 31. So again thread 2 will create new object and assign to ptr and it will resume and thread 1 now continue from 31. So ptr is already having an object again it will create. So it is race condition happening and critical this line 30 to 32 is a critical section. So this is not a proper code. So to make it thread safe, what we can do is we can introduce the mutex and this critical section can be guarded using a lockout. Using this mutex and only one. So this section is critical section. So this is the critical section. So I am making. So I am writing this. So I am making. I am locking the mutex using lockout, and this is the proper code. Now the multi-threaded application also will work because when one thread enter this acquire the mutex and enter the if condition, another thread cannot access this mutex because it is already locked, so there is no issue. Here there is a performance issue here. If you see the code is perfect but there is a performance issue and we can optimize this better. What is the issue is this lockout mutex every time it enters this get instance method it will be locked every time, but it need not require to lock every time. Only if the pointer is null, that time the critical race condition happens. Only if pointer is null. If it is not null means it will directly return. So there is no race condition. If it is null, that time only we have critical section. So null, if it is null, that time only we need to lock the mutex. So other time we don't need to lock. Whatever how many thread accessing there is no issue. So but here every time it is getting locked, so there is performance issue. So this can be optimized by adding a condition like whenever this pointer is null, that time alone lock the mutex and create. So this is one optimization we can have it in the code to improve the performance. Just we are doing double check. Okay, so this is about singleton design pattern. So this is the final code for singleton class. Thank you guys.